Hey guys, welcome to Split or Steal game on blockchain tutorial. This is a very simple game. First of all, what all you need to play this game. Currently, this game is available only on desktop, and you would need Firefox, Opera, or Chrome, either of these three browsers, in order to play the game. And you would need to install MetaMask plugin, which is basically a plugin which talks to the Ethereum blockchain um, from your browser. So get this extension on either Chrome, Firefox, or Opera, and you're ready to play the game. Now let's see what this game is about. Basically a very simple game which basically works on just three inputs, um, which is X, Y, and K, where X is basically a bet amount by some player 1, and Y is the bet amount from some player 2, and K is basically a rewarding factor, which is between 1 and 2 always. Um, so the game is very simple. Uh, it's a two-player game. One of the player chooses X amount to bet. Let's assume they choose 2 ethers to bet, and the other player chooses, let's say, 3 ethers to bet. Now what happens is, apart from betting an amount of ether, the players also have to choose whether they want to split or they want to steal. And the game goes like this. If both the players choose to split, they get x plus y by 2. That is, if I bet 2 and my opponent bet 3, the total is 5, both of us will get 2.5 ethers. So essentially, the player who bet less, which is me in this case, just 1.5 ethers. The player who bet higher just lost zero point 0.5 ethers here. Now, this particular case doesn't depend on K. This is the only case which doesn't depend on K. This is basically a case where both the players have chose to split, and as an effect, uh, both of the players' bet amounts have been added and divided by 2 and given to each of them. As simple as that. Now, the other case is one of the player chooses to steal, whereas the other player chooses to split. So, let's take an example. Let's say I choose to bet 1 ether and my opponent bets 0.05 ether, or let's say 0.5 ether, and I choose to steal whereas my opponent chooses to split. Then what the reward metric says is that the person who chooses to steal gets away with k into x times k into x of his bet. Basically, this means that if I bet 1 and value of k is 1.25, I get 1.25 ethers, whereas my opponent gets nothing. But this value is also capped by x plus y. So let's assume I bet 1 ether and my opponent bet 1.05 ether, 0.05 ether. Then I will not be getting 1.25. In fact, I'll be getting 1.05 only, because this amount of reward is capped by the total amount of bet. Okay, this was just a corner case that I wanted to cover in this tutorial. So basically, the case is one of the player chooses to steal and the other one splits. The player who steals wins k times his bet amount. K being the rewarding factor, which is currently set to be 1.25. It will always and always be between 1 and 2. It will always be greater than 1 and it will always be less than equal to 2. So, sorry. So, now let's go to the final case, which is steal and steal. So, if both the players who are playing the game, they choose to steal, only the player who bets higher takes away some of the amount. He also loses. The other person definitely loses all the amount, but the player who bets higher manages to get some amount back. Here's how. The reward metric says that if both the players steal, then each of them get max of 0, 2 minus k into x minus y by 2. So the player who chooses to bet higher, which is, let's say, me in this case, I get 1 minus zero point 0.5 by 2, which is 0.25, into 0.75, which is 0.1875. Whereas the opponent gets 0, because x minus y will be negative in that case, and hence he gets 0. So this is a very simple game which has uh, these outcomes. It's played on this reward matrix. The value of k is set by the game owner, and you can always see when the value of k was changed. And but if the value of k is changed when your game is in progress, it doesn't affect your game. Your game continues to run on the previous value of k as when the game was starting. So do not worry about that. Um, let's try to play one game, and let's see what all a player has to do when he's playing the game. So let's assume that there are two players. One of them is on Chrome and the other one is on, let's say, Opera. Alright. Let's say this is player 1. Hi player 1. And he wants to create a game. He could also choose to join a game. But let's say in this example, we say that he wants to create a game and he wants to do a game where he bets 1 ether and he wants to steal. Now, as you can see here, you do not have to write steal here. What you have to do is you have to either enter an odd number for split or an even number for steal. So let's assume that this player wants to steal and he enters 42 as it's an even number. He clicks on start game, he confirms the transaction, and this transaction will be sent to the blockchain. You can see that from your MetaMask browser plugin. If you click on the latest transaction, you'll see that your transaction is recorded on rinkeby.etherscan.io. Um, oh, sorry, I forgot to tell you in the starting that basically we are playing this game on Rinkeby network for this tutorial, whereas if you play it on main Ethereum network, actually ethers will be involved. Oh, so we see just now that this game has been created as your transaction has confirmed. So what is happening is that I have bet 1 ether, and now it is showing me an option to abandon the game. The abandon the game is basically if a player who started the game, if let's say he thinks that nobody is joining, he can just click on abandon game and his amount will be refunded back to his wallet. As simple as that. There's a slight catch here that if a player chooses to abandon the game before stage timeout, then the player's bet amount is refunded, deducting the game fees. Game fees is basically 0.0001 ether. So, and as you can see here, stage timeout is 7 days. So if you choose to abandon your game before 7 days, you will be charged this petty amount. So better to let your game running there. Alright, now as you can see, the other person gets to see this game. He says this game number 6. He bets, let's say, amount 1.5 ethers, or let's say 1.5 ethers, and he wants to do a steal, let's say. This guy did a steal. Let's say that this guy wants to do a split. So let's say he chooses 41. As 41 is an odd number, this signifies split. So you do a join game and you submit your transaction. This transaction will go on the blockchain. You can see it here, just like we did for the other player. It will take some time to confirm. I'll just go a bit deep in what is happening with the player's transactions. So as you can see, this player 1's transaction, um, who created the game, you can see a method on smart contract protocol with start game, but nobody can see what was his encrypted choice. This basically is commit reveal scheme, as we call it in this game. So player has committed his choice, but has only submitted an encrypted format of it on the blockchain, as blockchain data is visible to everyone. So similarly for the other player, uh, his encrypted choice is also not visible to anyone, but there is only one and only one way to verify that they chose to steal or split is by revealing their original choice. So in this case, his original choice was 42. So this game is in reveal mode, so he chooses to reveal his choice. Now what the smart contract will do is this 42 will go to blockchain, and smart contract would again hash it and try to match the previous hash that the game player had submitted. Only if they match, they consider that this player has actually done a steal. Now, when this transaction gets over, this player will actually see that now you can. Uh, what this player will actually see is that if the other player has not revealed his choice, this player would see that okay, we are waiting for someone to reveal your choice. Uh, so this transaction is still going on. So let's do okay, waiting for opponent to reveal the choice. Let's say the other player comes and he enters his choice, which was I think split. So we'll do a reveal and submit the choice and done. We are done here. So let's see this transaction on the blockchain. It might sometimes what can happen is it might take some time to be visible on the blockchain as these transactions are broadcasted and it might take some time basically. Uh, so while this is happening, you can see that for this user, this game is currently in waiting for opponent to reveal choice state, whereas for this user, I think the transaction is complete now. So now you are seeing claim reward here and you're also seeing claim reward here. So now what will happen? Since this player chose to steal, whereas this player chose to split, this player is gonna win some amount of ethers. Okay? So this player had bet 1 ether, this player had bet 1.5 ether, this 1.5 ether will completely be gone, whereas this guy will win 1.25 ethers. Let's just see how. Click on claim reward, click on submit, your transaction will go to the blockchain. The smart contract would evaluate that what should be rewarded to this player based on the choice this player made and the opponent made. And similarly, what we can do is we can do this claim reward stuff for the other player as well. Meanwhile, the other player is uh, getting to know about what is happening. So as you can see, this transaction is confirmed, and you can see that you have claimed your reward and you bet 1 ether and you won 1.2499 ether. Whereas this guy should have won 1.25 ethers, but he won 1.2499. As you can see in game rules section, um, there is something called a game fees. Game fees is 0.0001 ether, which is not even 0.1% of what this player had actually bet. So it should be pretty cool. So game fees is basically reward would be given after deducting game fees from reward amount. It's as simple as that. And there is something called minimum bet also here. The minimum bet on this network is zero point 0.1 ether, whereas maximum bet is 5 ether. Alright, let's see what the other player got. So, as expected, the other player who had bet 1.5 ether and had chosen to split actually won 0 ethers. So, this guy actually lost here in this particular example. Um, Similarly, if let's say the game was both the players had chosen to split, this player would have got a very small amount. Alright, so that's all about the game. If you like the game, please like it on Facebook, and you can also join our Telegram channel, follow me on Twitter, and do check out the code on GitHub. Thank you so much.